When you multiply numbers such as 3 times by 4, you have learned how to do this by virtue of your table. So you can say that is equal to 12. If you have something a little bit more complex, such as 12 times by 15, you've learned how to use a technique such as vertical multiplication. To say 12 times by 15, and then we say 5 times by 2 is 10, carry the 1. 5 times by 1 plus 1 is 6, then put a 0. When you move to the next column, 1 times by 2 is 2, 1 times by 1 is 1. Draw a line and add those together, so it's 0, 8, and 1. In other words, 12 times by 15 is 180. These are all techniques that you can use when working with numbers. However, if we take a look at the 12 times by 15, there's a different technique as well that you could have used without the vertical multiplication. You could have said, let's take the 12 and the 15 and break it down into 10 plus 2 times by 10 plus 5. And then you go through a sequence of multiplication where you say 10 times by 10 is 100, 10 times by 5 is 50, 2 times by 10 is 20, and 2 times by 5 is 10. Now let's add all of these together, and that gives us 180 as well. You get the same answer. Now this specific technique that we've used here is being taught from primary school, and it's known as the distributive law. And the distributive law essentially allows you to multiply brackets out. Now in algebra, the same principle is required when you get questions such as these. Different variations on multiplication of brackets. Now there is a technique known as FOIL, which stands for first, outers, inners, and last, if you have something like this, where you've got two brackets that you need to multiply. However, it only works with that specific scenario. When you've got something like that and when you've got something like that, it doesn't really apply anymore. So I'm going to show you another technique which comes back to what we've done there. If you look at the 4 arrows that I've drawn, those allow you to multiply any combination of brackets. And the principle behind that is the following. For the first one, take the x or whatever is standing at the front and multiply with every single term inside the bracket. So essentially we have 1, 2 brackets, and we are going to take those 2 brackets individually. So bracket number 1 is x times by x, that gives us x squared. Then for bracket number 2, we've got x times by minus 2, and that will give us minus 2x. Now just something that you need to remember when you are multiplying or when you are dividing in algebra is the following. Try and remember this. It's SNV, and it stands for signs, then the numbers, and then the variables. And we are going to come back to this a number of times. Signs requires that you multiply a plus and a minus times by a minus, a plus times by a minus, or a minus times by a plus. And what you can remember that is the following. If the signs are exactly the same, such as a plus times by a plus and a minus times by a minus, your answer is always going to be positive. And if the signs are different, your answer is always going to be negative. Step 2, the numbers is just simply tables or numbers, multiplication of numbers. There's nothing new to that for you. And then the variables requires your exponential laws. So when you multiply the variables, you need to understand and know how to work with exponents. But we'll come to that if required as well. For now, just looking at the first question, we've got the x at the front and the x inside the bracket with nothing in front of them. So you can assume that if there is no sign in front of a variable, it is going to be a positive. So that's a positive and a positive. You can further assume that if there's no number, it is a 1. So looking at the first arrow then, again from the perspective of the SNV rule, we'll say plus times by plus is plus, then the numbers, 1 times by 1 is 1, and then the variables, x times by x is x squared. That's where the exponents now come in. X times by x is different from x plus x. And if you have x times by x, the first exponential law says that is exponent 1, that is exponent 1. You are multiplying two variables, which are the same. So you're multiplying two bases, which are the same. Then you can just simply add the exponents, and that's where the x to the power of 2 comes from. When we move to arrow number 2, we've got a plus times by a minus. That gives us a minus. Then the 1 times by 2 is 2, and then the variables there is only the one x, which is why that then became just the x. So that is your final answer. You can't add those two terms again because they are not like terms. You cannot take it any further than just that. That is your final answer. When we now look at the second example, we just extend on the arrows that we've drawn by saying, let's start with the first term in the first bracket. And we draw an arrow to every single term in the second bracket. And we do the same for the second term in the first bracket. Draw an arrow to every single term in the second bracket. Which leaves us now with 1, 2, 3, 4 arrows. So taking arrow number 1, we've got x times by x. That will give us x squared. Arrow number 2 will give us x times by 4. And you can take them through the SNV rules if you want. I'm just going to run through it quickly. So x times by 4 will give us plus 4x. Arrow number 3, minus 2 times by x is minus 2x. And then arrow number 4, minus 2 times by plus 4 will give us minus 8. No variables there. But then you'll also notice that these middle two terms can be added together because they are similar. They look exactly the same in terms of their variables. You can say it's 4 apples minus 2 apples. So the final answer there will then be x squared plus 2x minus 8. We've just added those two terms together. When we go to the third example, you will now understand why it's so important to use the arrows and this whole technique of the distributive law, because now we say again, take the first term in the first bracket and draw an arrow to every single term in the second bracket. Then we take the next term in the second bracket and we draw an arrow to every single term in the second bracket, leaving us now with 1, 2, 3, 4, 5, 6 arrows. But it's very easy because you just extend the number of arrows. You don't have to get a new technique such as for a set of brackets like that. You just extend it a little bit further. So now looking at arrow number 1, we've got x times by x squared. That will give us x to the power of 3. Arrow number 2 is x times by plus 6x, or plus 1x times by plus 6x if you like. That will give you plus 6x squared. Arrow number 3, x times by minus 14 is minus 14x. Then arrow number 4, minus 3 times by x squared is minus 3x squared. Arrow number 5, minus 3 times by plus 6 will give us minus 18x. And then the last arrow, minus 3 times by minus 14 is plus 42. And then you'll notice that the x squared there and the x squared there terms, they can be added together because they are similar. And the x and the x terms can be added as well because they are also exactly similar. So that will leave us with x cubed. There's nothing that we can add to that. 6x squared minus 3x squared will give us minus 3x squared. So then that will be those two terms. Minus 14 minus 18 will give us minus 32x. So those two terms then covered, and then plus 42. And that is it. Final answer for that. When we look at the last example, you'll notice now something very distinct. We've got a set of, or a term in front of the brackets, and then we've got two brackets. Essentially meaning we are multiplying 1, 2, 3 things with each other. Now what you can remember when you've got this, more than two things, three or more that are being multiplied, is to rather take two of them, multiply them out first, and only once you've done that, you put the answer in a set of brackets and then multiply with the third thing. So what we'll do in this case is to take the two brackets. Always a good idea to start with the two brackets first and multiply them out. So then we are back to the previous example where we take the first term in the first bracket and multiply with every single term in the second bracket. That will then give us 1, 2, 3, 4 terms, or 4 arrows. Arrow number 1 will give us minus 4bd. Arrow number 2 will give us plus 4be squared. Arrow number 3 will give us minus 8cd. And arrow number 4 will give us plus 8ce squared. And then, like I said, we put that in a set of brackets, and then only do we multiply with the minus 3a. There's nothing inside those set of brackets that we can add together to simplify it, so that is it. We've got a term at the front, and it needs to be multiplied with all 4 terms inside the bracket. So then again, we'll just draw an arrow from the term outside the bracket to every single term inside the bracket. So first of all, to multiply the brackets out, we used the same technique as we've had over there. And now to multiply the third term, the one that's standing at the front, we'll use the technique we looked at right at the beginning. And you'll see it always remains the same technique. So it's always arrows that you can draw. And now we've got 4 arrows, and that will then give us, for arrow number 1, minus times a minus is a plus. Then the 3 times by the 4 is 12. And then 8 times by BD is ABD. Then we move to the second arrow. Minus times a plus is a minus. 3 times by 4 is 12. And then ABE squared. Nothing in terms of the variables that we can do there. Arrow number 3, minus times a minus is a plus. 3 times by 8 is 24. 8 times by C times by D gives us ACD. And then for arrow number 4, minus times a plus is a minus. 3 times by 4 is 24. And then we've got ACE squared. And there's nothing that we can do about any of those terms as well. We can't add them and simplify it further. So that is it then. Then we've got essentially the answer of the original 3 terms that were multiplied by just taking it in little steps as we go along. Now there are even more variations on these that you might encounter, such as, for instance, let's say x plus 2 plus c in a set of brackets multiplied with a plus b plus c in another set of brackets. Then you just follow the same thinking. Take the first term in the first bracket, draw an arrow to every single term in the second bracket. Then you take the next term in the first bracket and you draw an arrow to every single term in the second bracket. Then you take the next term in the first bracket and you just draw an arrow to every single term in the second bracket. It always remains the same technique with the SNV rule. You just multiply arrow by arrow by arrow. And then you might get something like the following, where they give you, let's say, x plus 2 and then x squared, something like that, plus 3x squared. Let's say you get something like that. You need to remember that the plus separates the 2 terms. So we are not even going to look at the plus 3x squared for now. It's got nothing to do with the multiplication. The same would have applied if we looked at any of these and there was a term or more terms at the left-hand side, but there's a plus or a minus between them. You don't look at that until you've multiplied the brackets out. But then we also look at this x squared at the front and at the back and realize that we can just move it to the front. So that then could very easily become x squared times by x plus 2 plus 3x squared. Then we're back to just multiplying this one term from the front into the brackets. So then that will give us x to the power of 3 plus 2x squared, arrow number 1, arrow number 2, and then you add that, plus 3x squared, and you'll observe that those 2 terms can be added together. So that will then give us x cubed plus 5x squared. But you could also have had this, minus, bracket, x plus 2 x squared plus 3x squared. Let's make it even more interesting. Let's say you had something like 4x cubed right at the front. Now you need to remember, we've got the minus there, we've got the plus over there, meaning that that term and that term has got nothing to do with the multiplication. We have to leave them out of the equation altogether. We need to multiply the brackets out first. So if we bring that x squared to the front, does it get multiplied with the minus, or does it just slot in this side or that side of the minus? Now essentially, you need to remember that we've got the 3 things being multiplied here. We've got the minus 1 at the front, multiplied with the bracket, multiplied with the x squared. So we could multiply these 2 terms with each other first, which will then give us minus x squared. That's then multiplied with the x plus 2 inside the brackets. But now it still has got nothing to do with the 2 terms on either side. So we can multiply the brackets out by saying, for the arrow number 1, we can say that's minus 1 and plus 1. So minus times by a plus is a minus. 1 times by 1 is 1. And then x to the power of 2 times by x will give us x to the power of 3. Then moving to arrow number 2, we've got minus x squared times by 2. So minus times by a plus is a minus. 1 times by 2 is 2, and then there is just the x squared term. Now we can add the other terms, 4x cubed and plus 3x squared. And we can say, okay, wait, there are two things that we can simplify. So that will give us 4x cubed minus 1x cubed is 3x cubed. And minus 2x squared plus 3x squared will give us plus 1x squared. Don't have to write the 1 there. And only now are we done with this whole simplification of something that we've started with a little bit earlier. So you can see that we can use the same technique all the time. All the time. You can use the same technique just by indicating arrows for the terms that you want to multiply. So it might be a good habit for you to acquire, to try and multiply your brackets out using this technique, rather than sticking with one technique that works for one set of brackets only.